ATS, Automotive Test Solutions.
Hello, how you all doing today? My name is Bernie Thompson, and today we're here to take a look at this 2013 Land Rover Sport. This Sport has a problem where we're setting misfire codes for all the cylinders on bank 1, and we're also setting lean mixture codes for bank 1. So this vehicle has been to the dealership and several European specialty shops. The individual has spent over $7,000 trying to fix this car. So what we want to do is we want to diagnose the car correctly. And in order to do that, the first thing we're going to need to do is get a scan tool on this vehicle and get some basic data. So let's go ahead and get that scan tool on this vehicle.
Yeah.
We have the scan tool up and we have some data. We're out on a test drive. Let's take a look at our data. So basically right away I can see bank 1 and bank 2 are both stoichiometric. Now bank 1 has a correction, and it's a large correction on fuel trim, and that's long term, and this is total trim. Bank 2 doesn't seem to have a trim issue, and basically I'm 8-9% of trim bank to bank. So that would tell me I have something going on bank 1 right now. The engine is warmed up, our vacuum is good, charging system is good. We have a pending code set, and 5 monitors haven't been set. We already know the 5 monitors, just because the shops have been trying to work on this car, and this car's been, they've done a lot of work on this car. So to have no codes, that doesn't really matter. We got to fix it anyway. Now right here we have a P0171. The bank 1 is too lean, and we can see that, and that is why I'm here, is to fix the bank 1 lean condition. Along with the lean condition, the shop is telling me that sometimes this car will set misfire codes for all 4 cylinders on bank 1, like I have a complete bank problem. Possibly maybe a cam or something would be out even. But it seems to appear that it would be on bank 1 is my problem. So basically I want to go ahead and we're going to go to get some more data here, and I can see where I have a long term of 16 and a short term of 4.3. So I've got about 22% total trim on bank 1. The long term on bank 2 is about 10 to 12% right here. So bank 1 has way more trim problem than bank 2. Bank 2 seems to be okay right now. So what I really want to do is I want to come over here and I want to go long plus short, and this is total trim, and this will give me a better idea of where my problem really is. Is it at idle? Is it light load? Is it moderate load? Is it heavy load, wide open? You really have to know where the trim is occurring, because it will change my diagnostic path. So let's go ahead and run this car, and we're going to see what we can't get here. Okay, so that really looks like it's down low is where my problem is more at an idle type of a problem on this car. So we basically have 23% and 11%. It definitely looks like the problem's on 1. We want to go ahead and we want to get another drive on this, another pull, just to see if any of these are going to fill out. So right away, it looks like I'm having more of a problem down low, and this is more of an idle issue than anywhere else. So that's really interesting. So I'm not sure what's going on here, but it really looks like the majority of my fuel trim issues are at idle. Now, the other thing you got to be very aware of is these codes have been cleared. Now, I could have trim issues up in these cells, but until the trim has run in that cell for enough fire cycles, it might not trim. Maybe they've been running it in their shop, and so I get trims down low, but I don't get them up in the middle. In other words, the way trim is done is it's the fire cycles by the trim authority. So if, let's say the program would say that I would have 100 fire cycles or 200 fire cycles, and for every 200 fire cycles, I could add 0.25% trim. And that would be one strategy. So that's why some cars like GM and Toyota, they have real rapid trim changes, because those numbers are, I have less fire cycles to more trim authority. If I've got Ford or a Honda, they take much longer. That means that they have more fire cycles with less trim authority. I'm not sure what these cars do. I don't work on a lot of Land Rover, but it looks right away like I have some type of problem down low and not up high. So what I want to do right now is I want to go ahead and I want to run a MAF sensor test, air pumping. So really what this is going to be is this is going to be how much I pump air. So we're all set here. So let's go ahead, and what this is going to do is it's going to tell me the ability of the engine to pump the air, and not only can it pump the air, but is it pumping enough air, and does the mass air read that air appropriately. So what you do is you just get it rolling, and then we're going to step into it wide open, and I'm going to make a full pull. We want to pull the gear. And that would be what we would expect to be here. We would expect this to do just what it did, and that is the air pulled all the way up, and right there when I got off of it, I felt the engine run really bad. It ran bad, like it was misfiring right there when I came back down to an idle. But this tells me that the air is being read right and we're pumping enough. To double check the reading, let me explain something. I don't have a known good engine here, so what I want to do is I want to go to power. And in power, it says this is my horsepower rating by the VIN of this car, and this is my corrected horsepower because I'm a mile high, and it's saying that I obtained that horsepower. Now if I made the horsepower, I pumped the right amount of air and I read the right amount of air. So when we look at these two charts, it's telling me that the problem is not on the air side. In other words, at least not under load. I can make the power and I'm okay as far as my mass goes, my mass airflow sensor. So what I need to be more worried about is what's going on with these trims, and I felt it really cut out at idle. So let's go over here, and I want to change a couple of things over here. So the first thing I want to do, I want to get all the data that we would normally collect first. I want to come over here, and it's what I want is I want total trim bank 1, total trim bank 2. And so this gives me an idea, and then we want to look at, say the map. That'll give me an idea of my vacuum rating. So right now, what I'm really interested in are these charts right here. I want to see what my total, look at that. I'm at 38% total trim on bank 1. Wow. Okay, so now what I want to do is we're going to restart this. And now I want to punch the car, because that's what I did when I just felt it run horrible. And then we're going to come to a stop again, and we're going to see what happens, but something's happening there. Or at least it did last time. It felt like it ran real bad. Now that time it did not do it. I did not feel it, and I don't see where we're trimmed as much either. So we're about 22, 23, and 10. This is still way too much trim, but I don't feel the car running bad. Let's go ahead and we're going to start to Get in it here. We're going to see what we get here for trims. Okay, it's running really bad right there. But I don't see my total trim changing a whole lot. We're still around 20%, but we definitely had it not run good. Okay, there we hit 45% trim right there, 42%, 34, 37, 28. So basically, that trim went up to almost 50% trim on bank 1, and we also had a problem on bank 2 at the same time, to where we hit almost 30% on bank 2. So what looks like it's on bank 1 is really on both of them. Bank 1 has more of a problem, but bank 2 also went to about 30%. This, what's really wild is that happened when I came back down to an idle. So now I know that we have something going on to where we're lean, and it looks like it might be both banks, not one bank. It just looks like it's worse on bank 1. So what I want to do now is I want to put a 5-gas analyzer on this car, and I want to get a tailpipe reading and match it against these readings here and see if we really need that trim. Maybe we have some type of a feedback problem, and that's why it runs bad. So let me get that gas analyzer connected to the car, and then let's check it to make sure that the correction is for real. I've got the 5-gas analyzer installed on this Land Rover. I've just put it in the tailpipe. I've taped this to the bumper and the side, and I've used painter's tape so it won't leave any residue on the paint. I've got the 5-gas on the back seat, and so now we're ready to read the data. So let's go for a ride. We have the 5-gas data up, so let's take a look at it. We've got 0.999, that's a lambda of 1. So that's stoichiometry. That means that we're controlling the fuel right now. So what I need to do is I want to go back over here, and we can see my total trim is 23%, and I can see I have a lambda of 1. I'm graphing the gas analyzer's gases on the same screen as we have scan data. So this is really handy for a problem like this. So basically bank 2's fuel trim isn't that far off. It's about 10%, but I've got 23%. Now what I want to do is I want to try to do what we did earlier, where I felt the car really run poorly. So I want to start to get in it. Then we're going to get out of it, and this is where I felt it run very poor before, so let's just see if it'll do it. It is an intermittent problem apparently. 48%, 39%, but my lambda stayed at a lambda of 1. I went from 1 to 1.02, that's a 2% change. So basically, I had a trim of close to 30% on bank 2, and I had a trim of almost 48% on bank 1. So bank 1 and bank 2 both had heavy fuel corrections under fuel trim, total trim, but my lambda stayed within 2%. Now guys, what that is a huge test for me, because now I know that the whole feedback system works. The O2s, the RAFs, whatever, all of that's going to work. And then the computer could see that data and it corrected it correctly. It made the right correction because what came out the tailpipe stayed at a lambda of 1. It was 1.02, that's 2% change. But I had almost a 50% change in fuel trims. So whatever the problem is, we now know that it's not air-based because the mass air sensor read correctly. We now know that our fuel that's delivered and burned stayed correct. we have a lambda of 1. So basically the computer is doing everything it can. It's not on the air side and it's not on the feedback side. So this problem is on the fuel side. It's a delivery problem. So maybe this car, let's just see something here. I want to go to PIDs. On some of these cars, we can get rail pressure. So I have the rail, and we've got a rail pressure just so we can see where we are here. So we're going to change the rail pressure into a different unit. So now it's in HG, so that's inches of mercury, and the conversion factor to PSI is 2.036. Just basically we're going to divide it by 2, and that's going to get us there. So right here we've got 870, 850, so roughly you've got about 450, 420 to 450, and I'd expect this car to have about 450 to 500 on the pressure. So let's go ahead and bring this up, and what I want to do is I want to change my setting over here for the rail pressure just to see if we've got some failure. So we're idling right now, and we have 860, 870, 880, so somewhere around 430 to 450, we'll say. It's bouncing around on my rail pressure. We do still have a lot of trim correction factors happening. So what I want to do here is let's go ahead and get my total trims. So these are my 2 total trims now. We can see we have a good correction on bank 2 as well as 1, but 1 is double, so it's way worse. So what I want to do now is I want to do the same thing. We're going to get in it. And I could feel it not pull very good that time. It just was flat. It didn't pull good. Okay, so that's 4. That's 250 pounds. That's half basically the pressure that we should have in this car. So I am losing my rail pressure, and we could also see the trim up for that, and we're keeping a lambda of 1. I am losing my fuel pressure in this car. Okay, so let's go back over here, and we can see that this is my fuel pressure. Oh, that's not. So let's move the data. This is a different graph, so what I need to do is I need to move the data. So let's change this, and we'll do this test again. I want the fuel pressure. We want total 1, and we want total for 2. Okay, so this will get us there. Let's clear the data. So now is what I want to do is that same thing again, but I want to graph it this time. It pulled a little bit better that time off the line. The other time it went flat on its face when I got into it. Okay, we went down to 500. Well, we should be at 900, or at least 850, 870. So we went really low, and at the same time that we went low, we have fuel trims here. So what we want to do is we want to take this, and I want to move this data. So here's my data, and we can see that we have our fuel pressure here, and we went to 42 when I first floored it, and that's HG, so that'd be 2,100 pounds. We'd come down, and we can see where we dropped right here. We can see, let's get the cursors, we're going to see where we dropped. So basically, we dropped to really small. So we went to 500, so that's about 250 psi, and we need to be at 450 to 500. That's basically half of the pressure fell away. And when that pressure fell away, let's see what the trims did down here. So here's my trim, and remember my reaction, it takes a little bit to react to that trim. That's 40%. So basically, I can see where I've got 40% trim, and the 40% trim came when I lost pressure. So I'm losing high pressure in the rail. Now, what that makes me think right away is I have a low pressure problem. So, what I want to do is I want to get an amp clamp, and I want to put an amp clamp on the fuel pump, and I want to see if the speed of that pump changes. If the speed of the pump is changing, it's telling me it's cavitating and it's not feeding the main rail. I also want to get the scope not only for the amp clamp for the pump, but I also want to get on the low and high pressure sensors on the computer. So I'm going to need to get a scope set up on this car, and so let me get that set up, and then we will get some more data to where we can try to figure it out. But the problem on this car is it's in the fuel side, and it's definitely, we're losing high rail pressure, and that's going to give us our problem that we're having. So let's try to figure out why we have that fuel pressure problem. This is the primary pump control. This is the pump that is in the fuel tank and drives the fuel to the engine. And you can see that I've got an amp clamp on it, and I'm into the control wire that gives me the duty cycle, so we can see how much command we're trying to make up out of this low pressure system. I've connected channel 1, the amp clamp, on the fuel pump control module on the main power wire, and I've connected channel 7 to the duty cycle that's going to drive it. Now, the main thing I'm interested in is the low pressure, so channel 2, red, is on the low pressure sensor for the low pressure fuel. Channel 3, green, is on the high pressure sensor for the high pressure fuel. Then I've got channel 4, blue, and channel 5, white. They're connected to the high pressure regulator. That is the control system that's controlling the regulated pressure. And then we've got purple, and that is on the fuel injector for number 1, and brown is on the ignition trigger for number 1. Now let's go ahead and get that data so we can try to figure out what's going on with this Land Rover. Now let's go ahead and get the scope configured. On channel 1 we have the amp clamp, and that is a 20 amp clamp, and that's on the fuel pump. So now is what we want to do is we want to go ahead and start the data capture. Let's start the car up. So this is the data that we're gathering off of it. Let's go ahead and shut this stuff off. I want to just look, mainly I just want to look at the fuel pressure right now to see what's going on with it. So we're going to take a zoom here, and we're going to zoom in on this. And what I'm really interested in, so this is the low pressure, this is the high pressure in green, this is the low pressure in red, this is my amp clamp. So what I'm really interested in is this is a 8 bar, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And basically we look at our hertz, and the hertz is 63. So we take the 63 times 60, and that gives me my RPM of the pump. So the RPM, if we cavitate, or we're aerating, this pump is going to change. I'm going to change the speed of this pump. It's going to be speeding up and slowing down, and that's what I want to check. So I would think at idle this would have about a 3 to 3,500 RPM pump. So that would appear to be correct. So we want to go, and we can see where my high pressure was up when we first started it. We're pushing more pressure, and then it comes down to a control level. So now that it's just been sitting here idling, let's go ahead and check it again. Now we can also come over here, and we can open these up, and the scan tool is reading the fuel pressure, so I know that I've got my rail pressure in that at this time, and my trims are doing pretty good right now too. For total trim and the other, they're close. So now is what we want to do is we want to go ahead and we want to zoom in on here. And we want to get in here, and basically I want to do the 8 bars again. So we want to just pick a bar, and then we want to come in, and that's 1, 2, 3, 4, 5, 6, 7, 8. And again, we have about 56, so we can try that again. So you take the 56 times 60, that's hertz, that's revolutions per minute. So we have about 33, and that's about what I would expect this pump to make. And again, we have the fuel pressure right now, so we're supplying that pressure. Let's check one more time over here, just because I'm trying to get an idea to make sure the pump isn't changing its speed. 2, 3, 4, 5, 6, 7, 8. And again, we're at 55. It's the same. It's not changing. So what I want to do now is I want to go ahead and I want to try to power break it to see if it might do it here. So we'll get in it. Okay, so we got 42K, 2100. I can feel it cutting out right there. So it's doing it right there. Wow. So it got way worse. So when I came down here, we dropped down. I'm going to go ahead and shut the ignition pulse off. We're going to get a cursor. We're going to come down here and we're going to measure this. And we can see my main rail pressure fell to about 1 volt. I want to go ahead and I want to do something else here too. I want to smooth the data on these two. These are my pressure. So this will just make it a little bit cleaner, and you can see where it just totally fell away. And we could also see that our pressure fell to 500. That's a couple of 100 pounds less than it should be, and the car started to run really bad right here. We now have a lot of trim going on as well. So is what I'm interested in is I want to see when this fell, what did this primary pump do? Is the primary pump aerating or having a problem? And that's really what the whole purpose of this is. So that's 1, 2, 3, 4, 5, 6, 7, 8. And again, we have about 54 hertz. So to give you the frequency there, missed one of those numbers. So we take 60, and then we're going to take the 54, 32. So basically the pump speed is really close. It didn't go way up. So if this pump starts to cavitate, it's going to spin faster, not slower. If it's not loaded by the fuel, the pump will go free. So we need to do a few times here to see if we get any cavitation. So we're going to come over here where it starts to fail, and we'll check this again over here. And I'm just trying to see if the pump is cavitating or putting air or losing its fuel. One, 2, 3, 4, 5, 6, 7. I need one more. 8. 54. So we're in the same spot again. We didn't change. So I'm going to come back over here. We're going to move a cursor. So I want my cursor to be at the lowest point. Right here is where the lowest point of pressure came. So did the pump slow down right over in here? So again, we're going to get our cursors, and I'm trying to measure this. I want to see if this primary pump is my problem. 1, 2, 3, 4, 5, 6, 7, 8. Okay, we're at 53, 45. We're just not changing. This is staying the same. Now, when we come back up, let's just see what we've got here. Oh, 56. So again, the RPM of the pump just isn't spinning. It's not getting aerated. Now this is my pressure, my low pressure, and we can see that that low pressure did not drop. It stayed steady the entire time, even though the high side was failing. It's falling right here. So I am maintaining my pressure. So the next thing I want to do is I want to take the frequency and I want to change these, and I want want to go to frequency, and now we want to plot that. Now what that does is that's telling me how hard I'm driving the pump. Now, I could have maintained the pressure and made it steady if I would have increased the duty cycle to the pump, but I would have seen the current coming up. And I don't see that current coming up, nor did the duty cycle try to drive it. So what that's telling me, guys, is this pump is staying loaded with fuel pressure and it's not cavitating. It's not getting air to where all of a sudden I'm giving this air to the high side. So the next thing that we've got to look at now is we have this data I want to go over, and we want to look at some other pieces of this data right now. So let's go out full. And where I'm interested in, let me make sure that we still have that marked where we're at our lowest point. So let's go ahead and take this. We're going to zoom out. I want the cursor. The cursor's over here where we totally fell. And we can see that we totally fell again over here. It fell here, and then it started to have a problem over here as well. So let's put a cursor here. And since we had another problem here, let's go ahead and just check the pressure right here of the pump. And we're checking the pressure with the pressure sensor, but we're also going to check how fast the pump is rotating. 1, 2, 3, 4, 5, 6, 7, 8. 54. It's not changing. The pump is not speeding up and slowing down, but the pump is staying very steady. So, and we can also see that in the pressure. So the low line pressure, I mean, look at when this dropped. Look at how steady that is. And we already saw that the command during this point isn't a problem. So what I want to do is I want to take the cursor and I want to come over here where I really felt it stumble the first time when I was watching it on the screen, and we could see our pressure took a big drop here as well. So now is what we want to do is we want to turn on some of this other data, and we want to try to figure out what's going on, because at this point I don't think that that's the low pressure side of this system. So we can see that the pump, do you see how much wider the pump started to drive right here? Now this pump, just so you guys know, there are dual pumps on this engine, 2 high pressure pumps, and there is a jack shaft that each cam has a 2 lobe, and the jack shaft is driven at 1:1 of the crank speed. So for every revolution the crank makes, I have 2 lobes that are just misconfigured that rotate around. That means that that pressure is going to have an increase each time I have a fuel injector come up to fire. So that's what you see here. These are the commands going to those pumps right here. So now I can see that my pump drive right here is getting wider and wider and wider, and this is where I drop my pressure. So we can go back here and we can see that we're not driving it as hard. We have way less drive over here. You can see this right here. So let's go ahead right in here, and we want to look at this data right in here where we're not having that problem. We can see that we're turning on for way less time right here. Now the purple is the fuel injector. So as what I'm interested in is I want to turn some of this other stuff off, and I want to find that. So here's our ignition, and this is the ignition timing, and I want to go off the ignition timing fall and fall. Now what I want to do is I want to go ahead and we want to bring up a firing order, intake. I'm going to smooth the data on those sensors so it's a little cleaner. And now I want to come in and we want to look at this. Now this is the high pressure line right here in green, and this is the low pressure line. Now let me explain this. The pump, when the pump plunger comes up, I'm timing when I'm going to close the valve, and then as it comes up, it forces that fuel. Once the fuel inlet is closed, it forces that fuel up in to the rail for high pressure. When that valve pops open, it changes. The low pressure side will change. So what I want to do is I want to watch the high pressure build, and then I want to see what happens in the low pressure side. So what we're going to do here is we're going to get our zoom window, and now I want to zoom in on this right here really tightly, and I want to go ahead and we're going to mark this down here again where we got a mark. Now we have the cylinders. Now do you see how this is firing and firing? Okay, this is the pressure. This right here is the high pressure being built in the pump. Do you see how I have these little spikes right here? Let me move this up so we can see this easier. And then I'm going to zoom in on it. So we'll take our zoom window and we're going to amplify that where we can see. Do you see how this is a pressure pulse right here? And this is, and this is, and this is, this. Let me turn on this. This is where we turn the pump on, and this is the other position we turn the pump on. You can see that those correspond to these little rises in the high pressure line. This is the high pressure line. Now what I'm interested in right now is the low pressure line. I close the valve, and do you see how I drop this drop? Well, that drop happens when I shut off the pump. So I'm shutting off the drive, and then what that does is that opens the valve, and then I get this pressure build, and then the next pump is going to turn on, and then we fire, and then we open the valve, and we're opening the valve, and we're bleeding up the pressure back into the main rail. Now there's very little fuel in that's going to come back out of this high pressure rail. It's a really high pressure, but there's not a lot of it, so it's hard to change the volume in the low side. But do you see how even and symmetric these all are? Do you see how I've got a hump and a hump and a hump and a hump? So that's what I expect. And this is when we're not having our problem. Now I want to go back out, and now I want to look at that same data, but I want to move it over here to where we're starting to have our problem, and I want to see. Oh wow, it did, it changed. This is so cool. I was wondering if it was going to do this. Okay, so now we're going to do the same thing. We're going to mark this off of our timing signal, our ignition, and always remember these pumps are timed, and the pumps are timed by crankshaft position. And that's whether I'm driving it by the cam or a jack shaft. It's using the timing from the crank to time when I'm turning these on and off. Again, you can see these pulses. Each one of these pulses is the piston coming up, making pressure. Again, I'm going to overlay these, and now you can see how much more duty cycle we have. Remember how you see how thick this is? We'll go back out and I'm going to show you so you fully understand. The computer sees that I've dropped pressure and it's trying to fix it. Now, what I want to do is I want to mark this. And is what I want you to see is the difference. Do you see how this one came up and it dropped all the way, and this one is up higher? And then do you see how flat this is? And do you see how flat this one is? And how flat this one is? Okay, so now we can go back and we can actually figure out what bank that is. Do you see how that's the bank for 3? That's where I'm firing 3. Now, each pump is going to fire the firing cycle. But this firing cycle fires 2 cylinders on one bank in a row and these 2 on another. So one pump feeds 2 cylinders on each side, so this wouldn't be a cylinder side issue. There's no way I can see that, okay? In other words, one pump, when I pulse one pump, they go into a common rail. First off, it's one common rail. But I build pressure, and one pump is building for the 2 outside, 1 and 7, and this is the 2 inside cylinders, 4 and 6. So, and the other pump is the 2 outside and the 2 inside, so it wouldn't give me a bank fuel trim problem, but I'm having a bank problem on one more than two, but both banks have a control issue. Okay, so now I want to zoom in so we can see what I'm seeing here, okay? So we're going to make these bigger. And then is what I want to do is we want to remark this so we can see our marks. Do you see how this one on 7, it fully, when that opened, when this valve opened, do you see how this fell right away? Do you see how these both fall? That's because the valve opened. And it drops, and then the pressure rises, and I have a clean ramp. And that's what we saw when we were not having the problem. We just looked at that. Now that we're having the problem, do you see how 2 has a problem and 3 has a problem? And we go back here, and this... Okay, so what this is telling me right here is I think that's pump 1 that's having my problem. And we can see this guy right here. But this is a high pressure pump failing. So I have 2 pumps on this car, and that's unusual. And to have a 2-lobed cam, I don't see many of that. This is 2 and it's on a jack shaft. It's not being cam driven. But what we're having here is, again, this is having a problem, and we can see that the pump, so the primary side, this is the low pressure side, is showing me that I'm having this problem. So now, if we go over here, and we're going to go over here and we're going to look at this again right before, and we can see where we started to build pressure here, and that's just because this came on so fast. Now, do you see how I've got these misformed humps over here? Do you see how this is totally misformed? Okay, so is what's happening with this car is we've got a problem with the high pressure pump. And I believe that this is the pump 1 because that would be on 3. So let's go over here and just look at where we had another failure over here, just because I want to confirm this. So we want to come in here and we can see that we're dropping pressure right here again. So let's see what happens here. And again, we have, it's not as obvious, but it's still there. And you'll see it here. So let's get the cursors. And then we're going to mark this. Okay, so we can see how this one is right. This one, 4 is right. 6 is right. This one isn't working right. 1 is right. And 7 is right. And these ones are having a problem. Now, I believe is what's causing this inside the high pressure pump intermittently is bleeding pressure. It's not working right. So I can't make the rail pressure, and at the same time, what's happening with this, let's go back over here where we didn't have the problem, right? And let's just look at this again so we can see the difference. Do you see how even all of these are? And this is the pressure running back. Now, if I had a fuel problem, if I had aeration going in, I would have both pumps affected. But I have every other lobe being affected. So you can see how these are real clean and they're all sort of even. And I still see some unevenness, but nothing like where we have our failure. And we can feel it when this happened. You could feel this car do this. So if we come in here, and we come right here, and let's go in here and we're going to look at this again. So we can see where this one stayed up way high. It didn't drop all the way. So let's get more data. So we're watching our pressure and we're watching our drop. So we dropped to 570, so that's low. And we can see that this is our pressure. So what I want to do is I want to smooth that. So I want to get this smoother here. And now I want to come in here and I want to look at that. And we can see right in here. And what I want to do is I want to take this and we want to move this across. And now is what I want to do is I want to mark that. Okay, so let's so we can see here where this one came all the way up and down and this one didn't. It's having a problem. This is having a problem. This is having a problem. It's every other one, and every other one is a different pump. These are my pump commands. Do you see how obvious that is? Okay, turn this off. And now I can see where I dropped all the way down and I had a full rib, just like we had before it had the problem. Do you see how you have a full one, and you have a full one, and you have a full one? That's every other one. This has to do with the high pressure pump having an issue. And we can come back up here and we can sort of look at this high pressure and we can see that the pressure is trying to fix it, but it just can't fix it. So what's happening here is we're having a problem with one of the high pressure pumps, and the pump is, there's a number one pump and a number two pump. The number one pump is the one that's having this issue. But I need to do one more thing. I need to go put an amp clamp on the two wires that drive these to make sure my current, that I don't have something happening to one pump and the current factor isn't there. So let me change the amp clamp from the back on the fuel pump drive to the front, and let's see what we got. Okay, so we've just added the amp clamp and we took it off of the low pressure side, and now we are on the two control wires for both of the high pressure regulators. So now let's go get that data. So let's go ahead and start it up, and it's what I need to make sure of is we don't have a current failure. So let's let it just get stabilized here. It starts, and as you can see, we make a lot of pressure to start the engine and to start it up, and then it will balance itself out. And now let's just see. Let's put it in gear. Okay, now it's running bad. Right there, I can feel it. Got the data, let's take a look at it. First thing I want to do is I want to shut down some of this data here so we can look at it. Now we can see that the red trace is the low pressure and the green trace is the high pressure, and I can see where the high pressure fell away here, so it's failing over here. So that's where I want to look at. I want to come right in here. We want to look at this. Okay, so all of the current flow to both solenoids is equal. We can see that. And that's about 5 amps, and that's what I expect, so that's good. The most important thing is one isn't low and one's high. They're all about the same, and I know they're going down, but the amp clamp was really difficult to get on, and I got it on backwards, and then I didn't invert it in my setup. But it doesn't make any difference. They're all equal. That's the most important thing. They're equal. Now what I want to make sure is it failing up here like it was before? So let's get our zoom window and let's zoom in on this waveform that we saw before. I want to make sure that it's still failing the same way, that every other one is failing while we have good amps. Because the amps are good right there and everything looks good. Let's make sure that the rest of it's the same. So we're going to mark this. Okay, that shouldn't be on intake. That needs to be on ignition. Okay, so 1 pulled up good. 2's flat, 7 pulled up good, 3's flat, 4 pulled up good, 5's flat, 6 pulled up good, 8's flat. So that's every other one, so that would be correct. Now, okay, so we can see it's falling here. So now is what I want to do is I want to go find a place where we don't have a problem. That's where we do have a problem. Let's look at where so let's come in right over here. These look okay here. The pressures it's not falling away here. I want to mark this on the number 1 ignition trigger. Okay, so we can see that all of these are even. We have good humps on all of them, so they're all humping. They're not flat, so that waveform's okay. So we don't have a problem right here. But wow, guys, I see something. Wow, look at that. I must have missed that, or maybe it wasn't like this. Maybe it's gotten worse, but I didn't see this before. Do you see where the peak pressure is building? Each one of these is the peak pressure. Do you see how far away this is from the top dead center mark? Do you see how close these are? Well, if I built pressure, we know the pump was turned on, because you can't build pressure unless the pump is turned on and activated. But let's just check that. Okay, for sure, it's okay. The pump is all equal. The pump drive is all equal. But the cam lobe is coming up in a different position compared to top dead center. We can see how you're real close here and you're real far away here. How far away are we there? So let's get the cursors and let's measure it. "35 degrees. That's 35 crankshaft degrees too early. If the waveform moves to the left, it's early. If it moves to the right, it's retarded or it's late. So you can see how these ones are all late and then they start getting earlier and earlier. Well, that's not coming from the drive changing. The computer driver, the computer commands not changing. They're all the same. It's just trying to make more pressure there. So this piston in the pump is coming up at a different time than it is over here. That's clearly what's going on here. Now, the only way that that could happen is if the jack shaft chain is loose. Wow, that's incredible, guys. This is really, really cool. Look at that. The jack shaft chain is loose. That's what's wrong with this car. And that answers a whole nother question to me that I've been looking to figure out the data. When we first worked on this car, we saw that I'd get in it and out of it, and that's when I'd get my problem. And I thought it was because I had the fuel sloshing, and when I sloshed the fuel, it was cavitating in the pump. And that's what I thought, it was cavitating. But no, when you get into it, you're stretching the chain out, and when you get out of it, the chain gets all loose and it starts whipping. That's what's going on. And now it's just gotten bad because we've been running it so long, the chain's hot and it's stretched out more. That's what's going on here, guys. It's just gotten worse because it's hot. This is incredible. What a crazy car, guys. This is a crazy car. But let's go ahead and check this again. So I want to go ahead and I want to set my zoom so we can come back. I want to go back and look at it where it's failing over here. So we know it's failing here. Let's go ahead and bring this one up. Mark this. Okay, yeah, each one of those peaks, let's blow this up more so we can see it better. Each one of those peaks is about the top dead center. They're all moved to the right, or they're retarded. They're retarded, right? So that's what's happening here. This is when the car is having a problem, and we can clearly see it because we're flat, 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 and flat, and that's what we've been chasing, is why this is flat. Now we know why it's flat. The jack shaft chain has got to be stretched. Something's wrong with that jack shaft chain. That's what's wrong. So we can clearly see this here. Okay, let's go back to where we were. Yeah, look at how far off these are. Do you see how far away those are from the top dead center markers? How close these are? This is like when it's failing over here. This is, wow, that's incredible, guys. This is really, really cool. Look at that. The jack shaft chain is loose. That's what's wrong with this car. It's just gotten worse because it's hot. This is incredible. This is the fuel line arrangement right here. So what we can see is this line right here comes off of the number 2 pump. This line down here comes off the number 1 pump. So what I want you to notice is how this line right here angles back down and this line goes straight across. Well, the reason that 2 doesn't have as big a problem is because it's going straight across and the volume is easier to push straight through rather than make a sharp or a tight angle to go back down. So even though bank 1 appeared to be the problem, both banks really have the problem, but the reason is because of the type of connection that's right here. What I want you to take away from this diagnostics is I want you to see how we did this. This was a very event-driven car. This is a really hard car. And what you've got to do is you've got to take data, understand why you did the test and what the data means, and then move to the next step, the next data step, do the test, understand the data, and as you can see, each one of these tests drove where I'm going next and what we're checking. Follow these simple type rules where you do event-driven diagnostics and you have quality tools, you too will have good troubleshooting in your base. Okay guys, the video you've been watching, I diagnosed this car here in town almost 5 years ago for a shop here. So it was during COVID and everyone wanted their cars fixed and they wanted them right away. So I diagnosed the car, the shop fixed the car, and then they called me, and before I could get down to get the data, the guy that owned the car had stopped to see if his car was done, and it was, so he took the car, so I'm out the data. So I talked to the shop, and they were going to try to get the car back, and we tried to get the car back, but I didn't get the car. Then about 2 years after that, the shop called me and he said, I have the car, come down. I'm in Detroit, I can't make that. So as soon as I got back, I went down and the car's gone again. So we've been working to get that car back for the last few years, and I was just down at the shop talking to him, and he told me, yeah, Bernie, that car, it's gone. He traded it in. So okay, so I'm going to release a video because there's no way I can get the data once it's done. That car's gone, and so the fixed car's data is gone. But I'll tell you something that the guy who owns the shop told me. He said, yeah, Bernie, you know, I doubted your diagnosis at the time, so I took a bore scope and I went down and I looked at it, and he said I could see where the guides were all chewed up from the chain moving around. He said, so we pulled the front cover off, and then he said, I saw the real problem. One of the guides was totally chewed up and the other guide was chewed up and it broke and it was totally off. Wasn't holding the chain at all. So now the chain's just whipping around. So once the chain's whipping around, the crankshaft and the pump shaft can't be timed together. But guys, there's a problem here. The engineer never thought that that chain was going to stretch or the guides were going to break, so the pump shaft couldn't go out of time. So there's no sensor on this shaft that reports the shaft's position. So that's why the dealers failed and all these other shops failed to fix this car, because all they're trying to use is a scan tool. And guys, you're not going to fix a car like this with a scan tool. What you're going to do with a scan tool is what happened to this car. High pressure pumps, high pressure sensor, RAF sensors, mass airflow sensor, a computer went on this car. You get every part but what it needs. Now, I can't see how you can fix this car with a scan tool because you can't see the chain. You don't know that that pump shaft's out of time without the way I've demonstrated using a scope here. This is the way you fix a car like this. And there's lots of really hard cars that I fix that the only way I can see to fix these cars is the way I'm demonstrating in these videos. With having a scope and having the understanding of how to use it and have a process to look over the data and understand the data and then let that make your diagnostic decisions. Okay guys, if you have good tools and good techniques, you too will have good troubleshooting in your base.